Hello everyone, welcome to this lecture on morphological analysis. In this lecture, we are going to discuss what is morphological analysis and its importance in natural language processing. We have techniques like lemmatization and stemming. We will discuss with examples and the sample code. So morphological analysis is basically a very important step in natural language processing. It is used to analyze the structure. It is used to analyze and study the structure of words and the formation of words. There are two types of morphological analysis. The first one is derivational morphology. The second one is inflectional morphology. In derivational morphology, we generate output form of words, changing the meaning or the grammatical form of words. So we may add suffixes or prefixes, whereas in inflectional morphology, we will generate words with um, some little bit of a suffix or something, and it does not change the meaning, but it may change the tense. For example, singular to plural. It can change the word cookie to cookies by adding s at the end of the word. In derivational morphology, for example, if you have the word like sad, and you can add ly as a suffix to convert into adverb form, so from adjective to another parts of speech. So this is very important to study and understand the structure and the formation of words, so that you can generate vocabularies in proper form. Features can be usable for further learning process by the machine learning algorithm or deep learning. So we have a method to break the words into several parts. We know. So after that, we apply this technique to um, deal with the various parts of constituent parts of the words, and it enables the NLP system to understand the purpose of the word and its meaning. So it is widely used in language modeling task and language generation, text classification, text clustering, information extraction, machine translation, and topic modeling and sentiment analysis. And in many of the NLP tasks, we use this approach. So first, we will see why it is important. This is used in building uh, blocks of words, and you can generate different forms of words to understand the meaning, and you can generate understandable form of words. You can identify the basic building blocks of words, and it enhances the accuracy of text analytics, and sentiment analysis or topic modeling can be improved by breaking the words into its root form. So language model also uses this approach to generate insights from words, and it can improve the performance of language models in speech recognition or text recognition. So morphology is used to improve the performance of language model. In multi-language processing, we have complex structure in different languages. So dealing with the complex structure of language, linguistic structure of words is one of the challenging tasks. It makes NLP systems more robust, applying this morphological analysis. And now let us discuss techniques involved in morphological analysis. We have stemming and lemmatization. And tokenization is the first step we discussed in the previous lecture. We have seen how to apply tokenization to split words into individual units. We applied word tokenization, subword tokenization, sentence tokenization, and character tokenization. So in this stemming process, we reduce the words to its base form. The base form can be generated by removing suffixes. So the word may become meaningless without meaning. Maybe the words may be invalid words, but it is useful for text normalization. So we apply streaming algorithm like Porter streamer, snowball streamer, or Lancaster streamer to do this. These are popular stemming algorithms used for this stemming process. It uses simple heuristic rules. It is easy to understand and easy to formulate, and it makes the process of learning faster. We strip suffixes, some prefixes, suffixes from words. We generate non-dictionary words in this process. So, for example, in this word cats, we remove the suffix s and we generate a stemmed word cat. And in the word fishing, we generate fish, uh, removing ing in it. And the word better remains the same. There is no change because it does not get reduced to because of the stemming algorithms. And now let us see what are the stemming algorithms we have. Porter stemmer is one of the simplest algorithm and most popular, and it is used to improve the efficiency of understanding, analyzing the words. And snowball stemmer is to support multiple languages. When you are working with the multilingual computing, it is used for dealing with the structure of the language and formation of words. And Lancaster summary is used to generate more shorter summary, and shorter sums can be generated from the given words. Now let's see one example using Python. So in Python we have NLTK package. You can use this to import Porter stemmer, and we create an instance of it. And now we assign the word running. For example, we need to convert this running into its base form run. So we pass this word as an argument and this stem function. So it now generates the word stem. So we'll discuss now advantages and disadvantages. It is used to improve the speed and the efficiency of algorithm, and it is a simple rule-based approach, so easy to understand rules, so it makes them less complex to implement and understand. Disadvantages are the words may be overly stemmed, or it may be underly stemmed. That may be the problem. So it will generate invalid words, which may cause confusion sometimes. Language limitation is there in this stemming process. Now, due to complex structure in the Chinese language or Japanese language, there may be difficulty in understanding the structure. So the words are in irregular format, it will be difficult to process. Now let us discuss lemmatization. Unlike the stemming process, lemmatization generates valid words which conforms to the meaning of or form of words in dictionary. So it also utilizes context and meaning of the words. It ensures that the base form of the words belong to the dictionary form. For example, running, ran, runs, all these can be converted into run. Better can be converted into good as per the dictionary format. And the WordNet tokenizer is one of the popular tokenizer used to uh, um, apply this process. It is a lemmatizer. WordNet lemmatizer is a freely available tool which can be used to implement this process. So now let us discuss advantages and disadvantages. When you are mainly concerned with the accuracy and contextual understanding of the text data, then we'll prefer this algorithm, limitation algorithm. It considers words, context, and the morphological analysis is used to generate base form of words, which are valid words. And when you are dealing with the ambiguity, you can convert words into dictionary form, so it will reduce the ambiguity, enhances clarity of text data. There are disadvantages in this limitation process, because the process may be computationally complex compared to the stemming process, and it is also uh, depending on the extensive language resources, specifically dictionary. You need a built-in dictionary, and you also depend on the morphological analysis. So that may be another disadvantage. So in this examples code, you can see we have imported WordNet WordNet lematizer and WordNet from the NLTK corpus, and we have downloaded the WordNet uh, dictionary and the average perceptron tagger. We are generating a POS tag. After getting the WordNet POS parts of speech tag for words, we are going to apply lematizer. So in this POS tag, we first generate a couple of words, and from that we fetch the first element, which is a tuple that contains the word and its parts of speech. Then we take the parts of speech from it, and first letter of the parts of speech is converted into uppercase. Now this dictionary format is used to return the tag dictionary. Uh, Now we are calling this WordNet lematizer. We are going to convert the word running into its base form, which conforms to the dictionary standard. So we pass word and get word net POS as a parameter, and then this lematize function. So it will generate lemma form of words that will be printed as output. Now you should understand how to use this stemming and lemmatization, and also you should understand when to use this, which one is preferred when you are developing an application. So if you are mainly focusing on improving the speed and the efficiency of an algorithm, your model, and you can prefer this stemming as a stemming algorithm. If you are going to improve the accuracy and you are implementing context awareness in the model, then limitation is a more preferred one. There are interesting applications of morphological analysis. This process can be applied for spell checking and grammar checking applications, where it can detect the misspelled words, you can make corrections, and you can deal with grammatical errors as well, converting it into word forms so you can understand their usage. Named entity recognition, you can classify named entities like organization name, person name, disease name, or house name, street name, or other names, place names, etc. You can understand morphological structure of the words. And information retrieval, you can improve the performance of search engine by matching proper words to the query, search query. So it will help the search engine to generate relevant results. In machine translation, you can translate the target language by understanding uh, the meaning and the correctness of the word. When you are having particularly different languages, so this plays a very important role to understand the words and meaning and the structure of the words. So in text to speech recognition also, morphological analysis is used to improve the pronunciation and tone, you can, so that you can accurately identify word structures and their stress patterns to detect who said the speech, or uh, whether the speech conveys correct meaning to the user. You can easily deal with the problem. So that's all in this lecture, guys. Thank you so much.